welcome to the show. It's me, John Park, and it's time for JP's product pick of the week. We've got a great one this week, and I hope you enjoy it. I also hope you run out and buy a whole bunch of them at a tremendous discount, because if you head over to this link right here, that's the product page. That'll take you right there if you use the QR code or this URL, handy URL right here. Head over there because we've got a 50% off discount on this week's product pick. A maximum of 10 per customer, no resellers allowed to play, so just regular customers. I believe we have plenty of them in stock. And all you have to do is put it in your cart. There's no coupon code or anything like that. Make sure you check out pretty close to the end of the show. It's a limited time that it will be at that discount. Check out and then await your goodies. And what I'd love to do next, actually, is have Lady Ada introduce us to this product pick when it was brand new. She did a little new segment on Ask an Engineer, and this is it.
So this is a new FeatherWing. This is, people really love our OLED FeatherWing that has 128 by 32 pixels. We've upgraded it. Now we found a display that fits perfectly on top. And it's 128 by 64 pixels. It's monochrome, and it still has the 3 buttons. It's still I2C. We've got an Arduino library for it. We don't quite yet have CircuitPython for it, but that's coming soon. So just be aware if you want to use it with CircuitPython or Python, that code is not available yet. But it's a beautiful display, and it's got, again, twice as many pixels. So that's kind of nice. And on the bottom, we even added a STEMMA QT connector. I'll get nice and close. So you can, maybe I'll show it off carefully. So you got the display over here, a STEMMA QT connector. So you can connect any I2C device you like, such as a sensor or like a air quality sensor or a relay or what have you, an ADC. So plugging this into my Feather. Okay, and then I'm going to plug this in. I can show that demo where we have, we have a no solder temperature humidity display using our HT20. Just plug it in, and I wrote some Arduino code to use this nice font, display the temperature and humidity. So chain as many sensors as you like. It's a great pairing for our 50 plus STEMMA boards, and it's a beautiful OLED display. So it's a big display with lots of pixels, and it's a perfect match for all of our feathers. So for folks who've been like, I want a bigger FeatherWing display, you got it.
Yes, that is right. So let me jump down to the downshooter here and get one for myself right here. I feel like I'm proposing or something, but here we go. Check that out. Ooh, yes. That is today's product pick of the week. It is the OLED FeatherWing 128 by 64 display. It's a monochrome display, beautiful screen on it. It plugs right into a feather if you solder in header pins. You can also use the STEMMA QT on the bottom. You could use that to connect to any board with I2C, or if you plop that onto a FeatherWing or doubler or tripler or quadrupler, you can use that STEMMA QT port to add another peripheral, another one of our STEMMA QT devices. It also has 3 general purpose buttons on there that you can use. And what I'll do is show you a couple of little demos that I have. So let me switch to the down shooter again. And we'll take a look at this one right here, actually. I haven't even peeled off the screen on that. I'll leave that on, the little screen protector. This one, since I haven't soldered it in, what I'll do is I will plug it into a feather. Here I have a Feather RP2040. I'll plug that in using the STEMMA QT, since this is an I2C display. And then I put some standoffs so I could pretend that it's plugged into a feather. That's the typical form factor that you'll get with a FeatherWing. And then let's power this up. And you can see here I have just a little demo of some graphics and text using our, oh, little reboot there. I have a little demo using graphics and text in our display I/O libraries. Really simple code to implement. And then what I'll do is actually show you a little bit more elaborate demo here where we can use some buttons on it and extra peripherals using STEMMA QT. So let me refocus this here. And I'm going to plug in power on this and then explain what the heck is going on here. First of all, you'll see I've got the gorgeous display there showing up. It always does this little second reboot. It is perfectly smooth in real life. Over video, you might see some little flicker on it depending on my exposure levels and the shutter speed of the camera here. So let me adjust exposure a little bit. Yeah, it was better before. Okay. So what you can see I've got here is my OLED FeatherWing plugged into a quadrupler. I have a feather, I have a little MIDI output, and I have our little Neo key little input for a couple mechanical key switches plugged in there with some cute kitty paw toe beans keycaps. What I'm doing here is sending MIDI to a MIDI device. In this case, it happens to be my Game Boy running Scott Shawcroft's CircuitPython cartridge there. And what I'll do, I'm going to restart this, and then when I press these two buttons, here we go, wake up, I can play a little tile grid animation. Zoom in there, in fact, now that you've seen this setup. There, little buddy. So this is Bongo Cat. And if I hold these are going to play a little sweep on the Game Boy, original Game Boy audio hardware. Now, the extra bonus here is that you can see I've plugged into the STEMMA QT port a little accelerometer. And as I tilt that accelerometer, I'm giving it a range of, I think, 1 to 7. And that's a variable that changes the rate of that sweep. So it's a pretty short sweep if I'm at 1. Gets a little longer, and even longer. It's also just plain fun to play with, but you can see this is a really neat use of the board. One of the fun things here is actually I'm using the same buttons on the side of the OLED, same pins as my feather, NeoKey feather there. So we can play those right on the side there. What's the point of that? It's just fun, that's all. But you can use this for all kinds of different things. It makes for such a nice clear display. You can see it's visible from some pretty extreme angles there. Sorry, my NeoPixels here are very bright. Nice and crisp, great for quick information type of display. And it's pretty fast. And you can see this is running over I²C, but that's fast enough to send information pretty quickly. It updates, refreshes pretty quickly as well. Like I said, it's 128 by 64 pixels. If you want to look at the code that's running this, let's switch to a different type of setup here. The code I've got running on this one, I'm importing some stuff for things like MIDI and using the buttons. Then I'm getting display I/O and terminal I/O so I can do display stuff and text stuff. And then I'm bringing in this display itself. The driver for this is display I/O SH1107. That's the display that we're using here. And then I'm also using image load to bring in that Bongo Cat sprite sheet and my accelerometer there. When I'm talking to the display, we set it up as a width of 128, a height of 64. I'm also putting a little border on it. And then to talk to the display, I'm sending really simple commands. Here I have tile grid 0 is set to position 2 or position 1 or position 0, and those are the three positions that the Bongo Cat can be in. And then I'm updating my text label .text using the string that I've derived from moving my accelerometer there. So you can see it's the very familiar, comfortable CircuitPython code for doing display stuff, and this display looks gorgeous. You can also use the Arduino library with this. If you have a project that's using Arduino, no problem. We have both CircuitPython and Arduino libraries for it. So let's see. Let me check the chats and see if anyone has questions. Tackle the World says, cute Bongo Cat electronics. What could be better? I don't know. It's great. It's so fun. And yeah, integrated accelerometer. So this could be anything you want. You can also daisy chain these or chain these together as long as you have unique addresses on the I2C bus, you can plug in multiple. You can see we have another STEMMA QT port there, so you can plug in multiple devices to get to the right configuration that you're looking for what you're trying to do. So you could have light sensors, proximity sensors, CO2 sensors, all of those types of things plugged right into a neat, compact feather arrangement. And like I said, this can be really compact because you can do the stacking feather thing, but you can also, since we have that STEMMA QT port, you could plug that right into things like a little cutie pie or other small microcontroller. It doesn't have to be used on a feather, which is kind of cool. Let's see, what else? I think maybe that'll do it. Someone asked, Ham's Lab asks about the name STEMMA and where that came from. Todd posits special technology for engaging microcontroller to microcontroller attachment. I love that. I don't think that's it, but it's a pretty good try. I think we have a page on this, in fact. Let me see. Actually, while I'm here, let me open this up. This is the main guide for it. So if you head to the product page here, let me refresh that to see. Yeah, we have them in stock still. Great. They're only $7.48. You can watch the video right inside of here. If you scroll down, you'll see there's a main guide. There's also a couple projects that use this part. If we head to the main guide, second page of this is the pinouts, and you'll see a nice, beautiful picture there of the displays, ribbon connector soldered in on the bottom side there, as well as some of these passives, and then our STEMMA QT port. And it'll let you know what pins are being used, which you can plug other, you can sort of stack things if you want to put this on top of another FeatherWing or side by side. Is particularly nice with the doublers and quadruplers and triplers because we're only using 4 pins for this. The ground, 3 volt, and these data and clock pins for I2C. Everything else is still open. You do have those optional buttons that you can enable. Don't have to use those. You could use those pins for other things if you want. And then we have a little mention of reset button that's on there, which is convenient, as well as the STEMMA QT port. And then if you continue on, you can get to some examples in CircuitPython and in Arduino for using that display. If we take a look at, there's an Adafruit STEMMA page. To answer the question maybe of what does that stand for, I can't remember, but I think it maybe doesn't stand for anything, but we liked the word STEM in there for science, technology, engineering, math. Yeah, I don't think it's an acronym for anything. Let's see. Yeah, we talk about the 2 types. We have the 3-pin and the 4-pin, so STEMMA and STEMMA QT, and then there's a couple different sizes of those connectors. Good question for Ask an Engineer. If you want to tune in tonight for Ask an Engineer, tomorrow night, Wednesday, and ask Lady Ada. She might have an answer for that. All right, let's see. Anything else? Any other questions? By the way, if you're wondering who am I talking to, this is our Discord. If you want to jump in, you can head to adafru.it/Discord and go to the live broadcast chat channel. And I think, yeah, that's it right there. Also, I'm keeping an eye over on the YouTube chat. So, Scotty asks, what's the min-max current draw? I'm not sure, actually. And if we have that anywhere, it would be in our specifications for the board. There's a data sheet that may tell you, but that might not be complete enough info. But you could head to the data sheet for the display and see. I'm guessing it won't be far off from that. McClath asks, where does Adafruit ship from? Rich Sadowski answers for us. Thank you. Yes, New York City. That's where we ship from. Scotty looked it up, or he's asking 24 to 29 milliamps. Yeah, not sure. And to answer this question, TR3BOR85 asks, to be clear, this has to be used with a feather? I cannot just connect it up via STEMMA QT port? No, you don't have to only use it with a feather. In fact, this example that I showed here, I happen to be using a feather, but it's over STEMMA QT. Maybe that's a little confusing. If you looked at the video that Lady Ada showed, she was using the cutie pie, I think, plugged into this, wasn't she? Or maybe I'm mistaking it, but this could be any board that has I2C. So I'm using one with the STEMMA QT port, which is the Feather RP2040. That could be a Cutie Pie M0, that could be an Itsy Bitsy, any microcontroller that has I2C. That port just makes it nice and easy to use this cable in particular, but Great question, and that makes this one a really versatile one because you could choose to put it on a feather, but you don't have to, so depending on how you want to use it. And I wasn't sure about that this morning. I was like, wait, is this one a SPI or I2C? It's I2C, which means we can use it right over STEMMA QT. If you wanted to use peripherals like this little accelerometer, along with this type of arrangement, you would need to get a little breakout for the I2C or breadboard or to use some other way because we don't have a second port. There wasn't room, so there's not a second port. So microcontroller to display is it for physical ports, but it's I2C, so we can add on lots of devices as long as you use something that branches out your STEMMA QT ports. All right, I think that's gonna do it. A really cool one. I love these little displays. That's my product pick of the week this week. It is the OLED FeatherWing. It's 128 by 64 I2C display with STEMMA QT port. And I will unplug it first and hang that up on my parts board of goodness right there. Be sure to head over, if you haven't, to that website right there if you want to buy one before the show is over, because the price will go back up. It's 50% off right now, and there's no coupon code. Just put it in your cart. Off you go. It'll be 50% off. That's going to do it for another JP's product pick of the week. That's me, JP. Thanks, everybody, and I'll see you next time. Bye-bye.